Welcome back, and today we are going to do a question called find subtree. So let's read it here. Given two binary trees, T and S, find if S has an equal subtree in T where the structure and the values are the same. Return true if it exists, otherwise return false. So that's pretty cool. And then here we have our skeleton that we can use. But first, let's go to the iPad. All right, so as you can see here, using our eyes, we could see that clearly tree S is inside of tree T, right? So that's good. So what we want to do is we want to return true here, okay? And then what we're gonna do is actually a little trick. We're gonna transform these trees into strings. And how we're gonna do that is we're gonna do a pre-order traversal. Right? And what is a pre-order traversal? Let me show you. Pre-order means you you print yourself before you print your children, right? So, and then this is how you do it. So for example, if we take T, the pre-order traversal would be 1, right? Because you want to print yourself, and then you recurse on left and right. All right. So then it's going to be 1, and then 4, and then 3, and then once you're in 3, you don't have any children, so you're not going to print anything. So then 4 will print the right children next, which is 2, and then 4 is done, and then 1 is going to start printing the right children, and then 1 would be 5, and then 4, and then minus 1. So that is the pre-order traversal. Okay, let's do tree S. So tree S is pretty simple. We start with yourself, 4, and then you print the left guy, the left children, and then the right children. Awesome. So then what you're gonna do is you're just gonna do a string algorithm. So you're gonna ask if this guy is inside this string. And yes, it is, because it's right here, right? And then you do a string matching algorithm. Super simple. So the first step is to transform those two trees into strings. And then what you do, you just do a string search. And we know from string search, if you use the, I don't know how to say this name, but the Knuth-Morris-Pratt algorithm, then the the search complexity, the time complexity for the search is O of n, where n is the bigger string, is a string that you're searching in, right? So that means here, in this case, it would be O of length T. Awesome. All right, so let's talk about time complexity more. So let's say that the length of T is m nodes, and then this guy, length of S, is n nodes. So then the algorithm that we just did, first what we have to do is we have to transform them into strings. So that means, let's see, pre-order traversal, pre-order, that would take m plus n. Awesome. And then the string search, that would take O of m. So then in the end, the big time complexity is m plus n. This is the time complexity. And then space complexity, since we have a string and a new string of length n, because those are the strings that we made out of these trees. So that means, let's see, the arrays, that would be O of m plus n. So yeah, so this is space. Yeah, so that's pretty much it. And let's start coding it. Okay, so we just have to fill in this function, fill this in. So very simple. First, we want to define another function called pre-order traversal that will create the string. Oops, I can't spell. Traversal. And then what we take is a node. And then what we want to return the string. Okay, awesome. So first, if it's nothing, we have to do the base case. So we just return the empty string, and then they can append to it. And then return, what do you want? Remember, what do we want? We want ourselves. So we want to print ourselves because it's a pre-order traversal. And then what you want to do is you want to print the left one, recurse on the left one, traversal, node left, and then to the right one, pre-order, can't spell, pre-order, yes, okay, awesome. Now that you have that function, what you want to do is you literally just call both of them pre-order traversal. First, I want to do the pre-order traversal this subtree, and I want to see if this string is in the bigger one, which is our big tree. And then if it's true, then it returns true. And then that's pretty much it. Let's see this example. This example is supposed to return true. Let's run it. All right, it returns true. Let's modify a little bit. So that's going to return false. I'm going to cancel this to here. So it's only 2 nodes now. So basically what I did was I deleted this guy. Yeah, I deleted this guy, rerun it, and it's false. Perfect. All right, so that's pretty much it. I hope this was useful, and thank you so much. See you in the next one.